All right, let's pick things up where we were before. I've still got my pulley. It is still frictionless. I still have a 2 kilogram mass attached to one side and a 3 kilogram mass attached to the other side. But this time I'm going to make it a pulley with infinite mass, which is ridiculous, but you're in a physics class, so we want to take things out to their ridiculous conclusions and see what happens. So if this pulley has all the mass of the universe and I attach a 3 kilogram mass and a 2 kilogram mass, they're going to be unable to move the universe at any real appreciable acceleration, right? So essentially, this thing is going to be unable to spin, right? It's so heavy that, sure, it spins, but it spins so slowly that we're not going to count it. So let's essentially say that the acceleration is 0. So if these things are not moving, then this is kind of an easy problem. If I have 20 newtons going down and this mass is not moving, I have to have 20 newtons going up. So T2 is equal to 20. The problem is over here, T3 has to be equal to 30, and our two tensions are no longer the same. It was true when our pulley was massless, because you had like instantaneous movement, and so whatever you had on the left, you basically had on the right. But now we're going to insert a delay, essentially. We're going to say that, sure, this 3 kilogram object is going to influence the 2 kilogram object, but it also has to influence the pulley, okay, because it's got to rotate the pulley. And so now we can no longer say that the two tensions are equal to each other, right? They're not, because the pulley is in the middle and the pulley needs to be dealt with. Okay, so let's take a real situation. Instead of saying that it has infinite mass, I'm going to give it a mass of 4 kilograms. Okay, so what we have here is we can start out where we started before, and we can say that T2 minus 20 is equal to 2A. Okay, same equation we had before. T3 minus 30 is equal to 3 times negative A, because we've kept our same reference frame. Going upward is positive. Okay, but it's now unsolvable. I've got three unknowns, A, T2, and T3, but I've only got 2 equations. So we have to deal with the pulley in order to figure out some more things. So let's start talking about the pulley. The pulley has torques on it, right? The pulley is not going to move up and down like the masses are, and so I don't have a sum of the forces equation. I guess you could say I do. Let's see. On the pulley, if I wanted to do the pulley itself, so here's my pulley. I've got T2, I've got T3, and there must be something attached to the pulley that's holding it upward. So call it T of the support. Okay, so in order for this contraption to work, I can't have my pulley falling or rising. Well, we could, but this is AP Physics 1. So we're going to lock our pulley in, and all our pulley does is spin. So this one, if I do T of the support, T2, and T3, they all have to equal 0. And I don't actually know what any of these are, so it's not going to help me much, and we're going to ignore it. Okay, so I don't really care about T of the support, essentially, is what we're going to get to. However, this thing does spin, right? So I've got 2 torques. I've got a torque here, call it torque 3, and that's equal to T3 times the radius, which is 1/2. So my radius up here is 1/2 meter, and my tension is operating at 1/2 meter away. I've got a torque on this side, T2. We're going to call that tension 2 times our radius of 1/2 meter. And now we need a reference frame. So the way that I solve these things is I'm going to assign some kind of rotation. So I'm going to say clockwise. Oops. Clockwise is positive. Okay. Again, I don't have to say that clockwise is positive. It's just how I'm going to solve it. So now I have to think through here, what is positive and what is negative. So this one over here, T3, pulling down, ooh, that goes in my clockwise direction. This is going to be positive. And this one, T2, is spinning the other way. That's going to be a negative. Okay. And the pulley itself is going to spin this direction. Okay, so the pulley itself is going to spin clockwise. So the pulley's movement also I am going to call positive. Now, there are other ways to solve these problems. This is just how I solve them because I think it's conceptually the easiest. But if you find ways on YouTube and you want to bring them in, we could definitely discuss them. Like, how are they similar to the way that I do it and how is it different? We'll go from there. Okay, so I've got these equations. So now I'm going to run a new thing, and I'm going to say that the sum of my torques is equal to I alpha. Okay, the sum of my torques is equal to I alpha. The sum of my torques is going to be T3 times 0.5 minus, because I'm making this a negative, T2 times 0.5, and that's equal to I alpha. Okay, you are not required to memorize I's unless they are for a single object, like a point object. So I need to tell you that for a pulley, for a disc, I is equal to 1/2 mr squared. Okay, so that would have to be told to you somewhere in the problem. I'm giving it to you. Usually they will provide you with either one equation or two, and they'll say like, oh, here's a sphere and here's a disc, and you're supposed to be able to say, oh, well, a pulley is a disc. I'm going to use the disc equation. Okay, but you do not need to memorize them or pull them out of thin air. Okay, so I'm going to erase this stuff for a second so I can clean up my math a little bit here. So I've got this 0.5 times T3 minus 0.5 times T2 equals 1/2. My mass is 4 kilograms over there. My radius is 0.5 times alpha. Okay. 0.5 squared is 0.25. And 0.25 times 4 is 1. So 0.25 times 4 times 1/2 is just going to reduce to 1/2. Okay. So now I've got T2 and T3, 2 variables. I've got A, 3 variables, and I've got alpha, 4 variables. Shoot. So I still have 4 variables, 3 equations. This damn thing is still not solvable. So what we're going to do is we are going to think way back to last week where I told you that A is equal to alpha R. Okay. A is equal to alpha R. So we're going to link our rotational equation to our linear equation. So this means that alpha is equal to A over R, and I'm going to plug in A over the radius of my pulley, which is 0.5. Let's get rid of this stuff. Okay, well this is actually pretty easy to solve. 0.5 divided by a 0.5, gonna cancel out. So I've got A. And now I have 1, 2, 3 unknowns and 1, 2, 3 equations. This thing is solvable. Okay, now, it's been a while since I solved one of these, and so when I did it this morning, I realized, ooh, there's a trick to this, and it's easier if you plug these guys whoop, in like so. So take your tension and plug them into your acceleration equation. I started out by solving for A, and then I plugged A into here, and I thought, oh, I just removed the variable that I want to solve for. So when you solve a pulley problem, take your two tensions and plug them into your rotation equation. Okay, do it that way. So I'm gonna have 0.5 times, oh, I forgot to solve for these in terms of each other. Okay, so T3 is, I'm gonna bring my 30 to the other side. So T3 is equal to 30 minus 3A minus 0.5, and T2 is equal to 20 plus 2A, right? I'm gonna bring my 20 to the other side. And that whole thing is equal to A. Okay, so solve for T3. T3 is gonna be, if I bring my 30 to the other side, 30 plus negative 3A. T2 is gonna be equal to 2A plus the 20 that I brought to the other side. So half of 30 is 15, minus half of 3 is 1.5, minus half of 20 is 10, and then minus half of A, or half of 2A is A, all equal to A. If we combine like terms, I'm gonna get 15 and negative 10, that's a 5. Negative 1.5 and negative A is negative 2.5A. Bring it to the other side and I get 5 equals negative 3.5A, or A equals 1.4 meters per second squared. So this is slower than the last time. Last time when we solved this as an old problem, I got an acceleration of 2. This time I get an acceleration of 1.4, because not only is the 3 pulling the 2 up, but it also has to cause the pulley to begin to spin. One last thing. Instead of solving for A, you could be asked to solve for alpha. What is the alpha for this thing? So I always solve for A every single time, and then I convert. So I know that A is equal to alpha R. So alpha is equal to A over R. I know my A is 1.4, and I know that my radius is 0.5. So this is going to be 2.8 radians per second squared. Okay. Are there other ways to solve these? There are. In fact, when my daughter took this class last year, her teacher showed them a different way. I just don't like it. But if you stumble across it and you want to discuss it, we can definitely do that.